Hi everyone, I'm Samir Rahi. This is Ashay Patel, Yasias Kasey, Jibril Kromachu, Nathan Solorzano, and Jonathan Asra, and we are Team Apollo presenting our project UAV Sound Detection and Localization. The problem that we're addressing is a very relevant and very prevalent one in society: what to do when you have an active shooter in an urban environment. Currently, first responders on the scene are delayed because they're unable to locate a shooter, and in addition to that, their lives are put in harm's way because of this uncertainty about where the shooter is. We are proposing a solution that utilizes two main components: a fleet of drones and a ground system for data analysis and computation. The best way to explain this is to do a quick walkthrough of what a use case would look like. If you look at that red circle on the bottom, we would have a fleet of 3 drones equipped with MEMS microphones backed with amplifiers and bandpass filters encircling a pre-input location at a radius of 100 to 200 meters. These drones would be feeding a constant relay of sound input back to our base station, and when a gunshot is fired, as indicated by that red X, that sound data would go back to the base station via a mesh-compatible Bluetooth low-energy network. When the sound data goes back to the base station, we have 2 main algorithms. The first one is focused on detection, and if you look at that graph on the top right, we have a myriad of factors that we're looking at to determine what constitutes a gunshot. Primarily, we're looking at the amplitude, and we're looking at the frequency and the time duration of that muzzle blast sound effect, as well as possibly the differentials between the sonic wave from a supersonic bullet and the muzzle itself, or the muzzle blast and the muzzle blast ground reflection. This is because gunshots have a combination of a very specific frequency and a very specific time duration of about, 17 to 21 milliseconds, that makes them unique from other similarly loud sounds. Once we have confirmed that the sound detected is a gunshot, we pass it off to the localization algorithm, which will attempt to create a vector from each drone to the sound source. This vector, of course, has 2 quantities: direction and magnitude. We attempt to establish direction by calculating the difference between the time difference between when different mics on different drones are hit by the sound source, and in that way triangulating the direction of each vector in relation to the drone. And in terms of distance, we're planning on using a combination of amplitude and a sort of reverse echolocation that tracks the difference between the initial sound source and the echoes of the gunshot, using planar wave technology that deals with, or planar wave mathematics that deals with the phase angles of the sound waves. Once we have localized the sound, which is, in a sense, created 3 vectors from each drone to the sound source, the end result of this data will be outputted in 2 places. First, on a graphical user interface overlaid onto a map, giving first readers an overall location of where the shooters are. And second, the location data will be sent to mobile devices, which will then go back to our drones to allow them to begin autonomous flight to encircle the sound source within a 5-meter radius. This will provide our first responders both a graphical cue as to where the shooter is, as well as a visual indicator that they're reaching the right altitude and location of the shooter. Overall, this will create a more accurate localization and detection system that overcomes the obstacles of traditional ground-based detection systems while ensuring the safety of civilians and our first responders. Thank you so much. We'll be taking some questions.
I'm trying to see the practical use of this. I mean, you have these 3 drones, I guess, flying over some area. I don't know where, probably.
Let's say a school campus or
school
something.
campus or somewhere. Okay. So you're anticipating already, or I mean, can you explain to me the practical use?
So part of the thing here is this would obviously there would have to be some report of a shooter or some sort of shooter threat. The idea here is, unfortunately, this is at best a mitigatory system. When a shot is fired, we are able to localize and trace in on that sound source so that our first responders can move to the scene without delay.
So there must be one prior shot incident reported, then you try to send despite these 3.
Yes, definitely going forward in the future, it's possible to integrate this with existing security camera systems so that we can identify threats beforehand. However, it was important for us to stay in scope of the project, that this is all about what to do once a shot is fired.
Okay, any plans to increase the range of 100?
We can, sorry, go ahead.
The Bluetooth modules we're using, they do generally have range of up to 1 kilometer, but we don't know exactly the effective, how strong the link would be at those ranges. And so we were given the parameters of around 100 and 200 meters, so that's what we're focusing on. But also the question that you asked about the purpose of it, this is just a generally a basic of what we're trying to do, but it can also be further implemented as in like live video feed into what the drones can see. So that can also give additional support to first responders on what's actually happening without actually putting like bodies into.
Yeah, additionally, we could also use this for search and rescue operations in forests and tweak the sound to identify like a human voice versus a gunshot.
I was gonna say, this sounds like it's a mesh network type of deal.
It is a
mesh
BLE
Yes.
mesh network.
Right. And you guys are gonna have to deal with, obviously, sound and amplitude's gonna become a big deal. When you get into, like I say, an urban environment, how I kind of assumed you guys were trying to do this from building, you're gonna have a lot of echoes and everything else. It sounded like you had an opportunity to try to address it, but sound's gonna get, decreased just because of the echoes and everything else. How are you guys gonna deal with that standpoint?
Well, I guess mainly our main focus right now, as of right now, is we've kind of ordered the parts to be able to, first off, be able to at least detect and localize the sound. And as far as like having to deal with an urban area like downtown Dallas, for instance, where there's a lot of echo, we're also trying to implement kind of like a reverse echo system, implementing like the SNR and such to eliminate such echo in that kind of sense. So this is something that we're kind of going to start working on more in like the next semester to come.
Yeah, and I think that definitely going back to like our overall detection philosophy, that like relatively speaking, even in an urban environment, a gunshot exists at a frequency that's much higher. So provided that our drones are within the 100-meter radius, at least right now, we know that our microphones would be strong enough to capture that like 17 to 21 milliseconds and the higher frequency.
Now, what happens, how do you determine the drone's location using
We set it.
Yeah.
So
Yeah.
we know the altitude at which we set it at. We know where they are. That's why when we do get calculate the direction, the magnitude and vectors of the sound from each drone, we can easily overlap it onto a map because we're setting those drone
use
coordinates.
the satellite location?
No, so
No.
You use GPS?
Yes,
Yeah.
we do.
Oh, you use
Yeah,
GPS.
the idea is if there's a threat reported, drones are deployed to the area, and then they're like set up around like a central location, let's say the building where the threat was reported, and at a preset altitude, and then when the shot is fired, the program kicks into
What if the
action.
shooter's outside the circle? Are you still okay?
So they are omnidirectional mics, so that they could, depending on the range of which they can detect, they could detect outside of that range. This is just generally what we're looking at. We're
Yeah.
trying to contain it into a specific radius.
And to build up on that, what we did is, so our second option is build a PCB and do an array of MEMS microphones so we can know exactly which vector is coming from. So if it does even come outside the radius, we would be capturing that. So whichever option is better would go through with that.
All right. That's it.